So welcome everybody. Can you hear me and see me all right? And do you see my slides?
Yes, we do.
Okay, I have to excuse myself for 2 seconds because I have to close the window because it's very cold here. Just a second. So I'm back. So very nice to meet you all. And here's our presentation. So I'm here with Johannes. Johannes, maybe you can briefly raise your hand and show that you're also there. That's Johannes. There are more people working on this, but it's the two of us presenting it here. So I want to give you a short overview. QLever is a SPARQL engine for large knowledge graphs. I want to show you first some queries, especially queries, typical queries which are slow on the Wikidata query service. I want to show you how easy it is to self up, say a little bit about the code base, about help with query construction. And you're very welcome to interrupt me at any time and ask questions. So let's start with a few queries. These are, so Johannes and I talked about it, and we thought about some typical queries which are not really very hard, but where the Wikidata query service has a hard time. So here's one example, and let me click on this and see if it works. Okay, it opened in another window. I have to drag it over here. Now my PowerPoint presentation, for some reason the PowerPoint presentation crashes when you click on a link, but that is just so. So that's a query that just asks for the top 10 movies from Wikidata, just the top 10 movies from Wikidata. And why is it, so if I go to the Wikidata query service, so this is our instance for Wikidata, the full Wikidata. I can click here, query another service, for example, the Wikidata query service. I can ask the same query here, and it will run a very long time. In fact, it will time out. Why will it time out, even if it's just 10 results? Because you have to look at all the movies. You have to look at all the movies and then sort them, and then you just get the top 10. That's a very frequent situation. We have looked at a lot of queries. That's what people do a lot. So you touch a lot of data. In the end, you only want little. But because you have to touch a lot of data in the middle, it takes a long time. Let's just verify. Oh, I'm sorry. No, for some reason, it has 0 results. That's, I think, because this side links things here is done differently in Wikidata. If I do it like this, Wikidata, this query service has all kinds of shortcuts to make the data more manageable. So it's slightly differing. So here's another one. This is, I want the highest mountain for every country. That's a similar one. You have to touch a lot of data. I'm sorry, I have to. But in the end, the result is relatively small. It's just 229 countries, and for each of them here, I get the highest peak. And I think if I will ask that the Wikidata query service, it will also have its problem. I think here it, okay, I'm not sure why it gets 0 results here. It should get, let's see what's happening here, but it's running for a long time. Okay, I'm having a bit of, PowerPoint presentation is crashing every time. That's really strange. Here's another one. That's a very simple query with a the PowerPoint presentation crashed again.
Maybe try right-clicking on the links and copying them. Maybe.
Yeah, I will do that. Yeah, I don't know why it crashes every time. So this is just asking for all people in Wikidata. And this is also something people will do. They want to just download maybe a partial data set. So there are 10 million people in Wikidata. They are here in no particular order. Let me also show you that you can just download them. So this is here a link for sharing it. Let me just, I'm here in a machine. So this is just a CURL query where I will now download the 10 million things. This is also something which I think you cannot do with the current query service. And I think we will just switch to the PDF for a second, because I have the PDF here and there the links should just work. Here's another one that's frequent. This is just this is statistics query. I think the Wikidata people themselves do that a lot. Here we just want to ask on the full Wikidata, which predicates are they? How large are they? Which percentage of the data do they have? So for example, RDF type here is a very big one. There are 3 billion triples. It's 18% of the data set. It also has the synonym instance of. I don't think you can see. It's a pretty abstract query which has to touch all the data. But it works. And this, by the way, this is the complete Wikidata which has 19 billion triples currently already. And here's another one. It's also it's also a kind of statistic queries where I ask, here I have people, and let me maybe rewrite this query a little bit. Here I have all entities of type person, so Q5 is type person. And let me maybe, if I could also have another type here, for example, we could also take, let's take something different. Let's maybe take proteins here. And now I want to know which other predicates do I have for the word protein, for entities of type protein. And here I get a list. So that's another kind of query which is very hard, but which you can do here pretty fast. So entities of type protein also have these predicates, instance of, found in taxon, encoded by. Let's maybe repeat it for human. If I type here human, so entities of type human, we have already seen there are 10 millions of them. What predicates do they have? Instance of, sex or gender, occupation, given name. So these are kinds of explorative queries which I think are very useful. And I think you can't do them with the current query service. Here's some more examples just to show you what's possible and how fast it is. This is a federated query just combining Wikidata and IMDb. So this is now asking for all the movies in Wikidata, and we want their IMDb score, which is in a different SPARQL endpoint. And here we just order them by the number of votes. So these elements here, IMDb votes, IMDb rating, we get them from a different SPARQL endpoint. You see it's quite a substantial number of results, 150,000 and a few more. This one is nice, the power network of the EU. This combines information from OpenStreetMap with Wikidata. Why do you need Wikidata? You need to know which countries are in the EU. This is not something which OpenStreet. So you see here this service thing. So this asking for power lines in OpenStreetMap. Let me just execute it and asking which countries are in the EU. I can also display it here, I think. Yes. Okay, here we get the power network of the EU. You see some countries are excluded here. That's the minus here. So this is asking for all countries in Wikidata which are in the European Union, minus those which have an end date. That's why you get this list. So if I zoom in here, I would, this now is a power line. If I click on it, it's something in OpenStreetMap. Let me go back to the slide. Here's another one. Geospatial queries, I think, are also interesting for a number of people. This is asking for all Wikidata objects in a circle around Freiburg, where we are currently, just to see that, so this is just Wiki. If I click on here, this is now some Chateau de Zeitz. Okay, and here we get the Wikidata entry. This is an interesting one here. That's another one just to show you the geospatial aspect for those of you who are interested in this. Here I can specify any region. It's also a SPARQL query. Let's take an unusual region, maybe the Alps, so the mountains. in, let me just select this. So that's now all. Okay, that was a bit too fast. I can always clear the cache here. QLever is remembering results and see how long it really works. So this took 3 seconds. And now let's look at the street network of the Alps. Here I have the street network of the Alps. If I click here and so on. Okay, maybe here's another one, a geospatial query. Maybe you can tell me a river, like a long, interesting river. That's another geospatial one. And we want to know through which countries it flows. So that's again an interesting geospatial query. Danube. Okay, let's take the Danube. That's a good one. We type it here. We get the Danube first. I will talk about this auto-completion in a second. And now I get deliberately chose some other language names here, German names. So we see it goes through Romania, Serbia, Germany, Bulgaria. And here it even generates as part of the Spark. SPARQL can do that. In case you didn't know, you can also create again as part of a result SPARQL queries. So maybe I just want to know the part of the Danube, Donau that goes through Germany. I click on this link. That's the part that goes through Germany, or maybe the part that goes through Romania. Then we should probably see a part of the Black Sea. Yeah, here it goes. That's the part of the Danube in. Yes. And okay, another one. 2 more, which are maybe interesting. You can also combine it with a text search. So in this instance here, we do not only have the complete Wikidata, we also have Wikipedia in there, the text, the abstracts. Yeah, Peter, I will come back to that question in a second, but maybe we collect those. So this is, wait, what was that query here? Movies, weather. Okay, that's not the. Okay, I have to pick. This was another example query here. This is again, it's movies from Wikidata with the scores from IMDb, where the Wikipedia abstract matches a certain word. So here I'm interested in whether it contains the word dream or something. Let's do that query. So that's now doing text search in Wikipedia as well. It takes 4 seconds, not such an easy query. So here I get inception first. Here I have the Wikipedia abstract. So Wikipedia is not normally in the Wikidata. The descriptions are very short, but you can have it here. And it's very useful. And here's another one. This is the one which was just there already. That's astronauts who walked on the moon, but now I'm asking where in Wikipedia does it say who walked on the moon? So I have 81 pieces from Wikipedia where it just says that someone, Neil Armstrong, walked on the moon, and I get this here. And you see these text queries. So some people want to combine text with SPARQL queries, and that also works. And now let me try to get my presentation back, because now I want my slides. So this I did from the PDF, because it always crashes for some reason. Give me 1 minute, a second. I don't need a minute, I just need a second. And this has, I think, to do with a combination with Jitsi. I usually present via Zoom. Just 1 second. Oh, I hear interesting breathing, or maybe it's aliens. Breathing sounds, or aliens. So I'm back to my presentation here. Sorry for this. Oh, I don't have too many slides, so I'm finished. Here's one more thing which I think is interesting. Let me just So it's very easy to set it out yourself. And let's just do that for a second. So pip PyPy at the moment has problems, so I'm not showing you that. You can just install it like this. You can set it up like this. If you want to run it yourself on your machine, a smaller collection or bigger one, you can do it very easily. And I just wanted to show it to you here. So a very small data set is Olympics, and let's just do it. So I'm in an empty directory here. Let me just show you. So I can just do the following. I can write QLever setup config Olympics. And now I get a configuration file. So I deliberately chose the font very large so that you can easily, this now created a pre-configured configuration file, which just says where is the data, how do you load it, and so on. So that's a small collection. Let me get the data. Now it gets the data, it downloads it from some GitHub. It's now there. It's a data set. It's just, I think, not so many. We see it. Yeah, it's just some triples here. And now let's, we call this indexing in QLever, loading the data. Okay, the data has loaded. And now I can start the server. I think it's already started, so I have to restart it. And now it's, okay, I'm not sure why this takes so long. I don't know what that was. I can also get this query interface if you want it here. So now it's what I just started is online here. It's just the same thing you have seen all the time. So this is something you can do yourself on your machine, and you get exact same thing with very few lines of code. And one more thing I want to show you. I want to show you a little bit larger collection. I mean, that was Olympics is really small. It's just a test collection, really. It's 2 million triples. So as you saw, this just takes a second or so. Let's take a little bit larger one. DBLP, that's computer science bibliography. Let's do the same thing here. The same sequence. So I want to, I first want to get the configuration. Somebody has already done that for us. So I get that here. This gives me this config file with some information. And now let's first download the data. This will now download it from some other site. We will see that takes some time, about 3 minutes. And while that goes on, let me go on with the remaining slides. And we will come back to this in 2 minutes and again in 2 minutes. So Olympics, this takes about 2 seconds. It's 2 million triples, just so that you get a feeling for how long this takes. DBLP is about 400 million triples. It's ready in 3 minutes. So to load it into QLever, and downloading it also takes 3 minutes. So like Wikidata 19 billion triples is ready in 4 hours. So it takes 4 hours to download and 4 hours to load it into QLever. So it's pretty fast. So it's really loading the data into the engine takes as long as downloading it. We can manage over 100 billion triples. So scale is not really a problem. Let me maybe also show you that briefly. I think I have here. So our currently largest instance is UniProt. That's a protein database. So if you go here, we have here 100 billion triples loaded into QLever. That takes a little bit longer. Let me show you one example query. For example, let's also explore here which predicates are there and how often do they occur. And as you can see, it also has RDF type UniProt 17 billion triples, so 15%. That's 17 billion. So just RDF type has as many triples as the, yes. So, and I should say this is not a special purpose machine. This is now a 2,000 euro machine, so a relatively cheap machine, because that's one of the design principles. And let's see whether we, okay, we have almost downloaded our DBLP data. And let's just, after we downloaded it, index it, and then go back to the presentation, just to show that it's really that. So it has now downloaded in about, let's now index it. That indexing is what we call loading the data. So let me maybe make the font a little smaller, and now it will index it, and we will come back to it, and let's see whether it's ready in 3 minutes. A bit about the code quality. So it's written in modern C++, very well documented. We have unit tests, code reviews, static analysis, continuous integration. So we build for various platforms, Ubuntu. It's oh, I didn't write this here. It's of course 100% open source. It can be used with Docker or compiled natively. It's there to stay. So it's not like an academic project. It's there to stay. Here's one more feature which I wanted to show you, which I think is interesting. Let's look at a query which takes a little longer. I think that's a very frequent situation for people, that you are sending a query and you're wondering, why does it take so long? Let's maybe take a very hard one. I want all the streets in a big country. I don't even know if it works. The complete street network of the United States as a query. That's a super hard query because it's a geometric contains query. That's a very hard predicate to compute here. Let's just let me clear the cache, make sure it's not stored before. Let me execute it. Now I can see what it's doing. And you see these are the operations the engine code's already finished. It's not so easy to find queries which take longer. Let me just repeat it. It took 6 seconds. So what you can see here is, you can see the progression of the query processing and where it's currently. So right now it's busy with this operation. So here you see, so this requires a bit of expert knowledge, but I think it's very useful if you know a bit more. While you're processing your query, you can look at what is the engine currently doing. Why is it taking so long? Maybe I made a mistake in my query. It's quite useful. So here we get the street network of the United States. We can also show it. Okay, drawing the whole street network on the map takes a little while. Yeah, there it is. It works. Okay, let's maybe, what's this? Las Vegas. Yeah, let's zoom into here. We get the street network of Las Vegas. So it really works. And that's now a piece of street in Las Vegas from OpenStreetMap. So if we zoom out here, yeah, that's the power of RDF and SPARQL. Okay, here's the last one. And then we can, let's see if the, okay, this is still busy. Typing SPARQL queries is hard. So we know that. I mean, people are struggling with, as I said yesterday in the presentation, this is really every query language is, of course, if you want to type complex queries, you have to know a bit about the language. Here's one which looks very simple. Which Oscars did Meryl Streep win and for which movies? She actually won 3 Oscars for these movies: Kramer versus Kramer, Sophie's Choice, The Iron Lady. That looks like a simple enough query, right? You just want this result, and this is the query. You can say it in one sentence in natural language. Well, this is the right SPARQL query. This is the right SPARQL query, and how on earth are you supposed to come up with this yourself, right? You have to know all these prefixes. You have to know P, P166, PS, PQ. You have to know these intricacies of the modeling. Wikidata has a query builder for that. We also have a query builder for that, and I just wanted to show it to you briefly, how it helps you to construct these queries. So here it is. So let me select, that's how all queries look like. So I want to know something about Meryl Streep. Let me type just Mary here. I get Meryl Streep. So I don't need to know that it's Q873. I just type the prefix of a name. And now I want to know something about awards. So let me just type award. And now the engine tells me, because these suggestions are now taken in context, the engine already knows it's about Meryl Streep. So, and it tells me, look, there are 2 versions of this predicate. So even if I'm not sure what it means, I can just try it out. So there's a version with P. Let me just select it. And now I see, this leads via these intermediate nodes, which are connected to more information. So let me just select a variable here. And now I'm at these intermediate statement nodes from Wikidata, which lead me to more information. And now it's very hard to figure out, if you don't know the data, which predicates are actually connected to awards of people, or to awards of Meryl Streep in this case. And here I just get the list, because these suggestions are in context of what there actually is, and it's very little. I don't have to understand what PSPQ means. I can just look at the textual description. So here I have the actual awards. And here I get the list of awards. So I don't want a particular one, I want all of them. So I take a variable. What else do I want? I want to know for which movie. I don't know the predicate, but which one of this is it? I mean, it's apparently for work. So I don't need to know that it's PQ, that it's P1686. And here I have the movies. So let me just select this. And now I also want to say that the award should not be any award, but it should be an Oscar. So let me select this. And now let's select what do we want to see. We want to see the award and the work. Now we would only get entities. Let's also add the labels automatically. And here I have the result. And maybe one final thing, and then I'm very happy to take your questions. I know the Wikidata people are also doing that. Language models are a great help in helping with query formulation. So here I've prepared something in ChatGPT. I just said, give me the coordinates of birthplaces of people with first name. I don't know, we can also take another name. Maybe let's take Peter, because he's also here. First name Peter in Wikidata. And please consider the following, let me just ask that ChatGPT. So I'm just telling ChatGPT to write me a SPARQL query from a natural language description. And let me just copy this and see if it works. And the problem is I get 0 results because it almost works, but these language models don't get right is the IDs. So this is actually not the first name Patrick. This is something else. It just hallucinated this. And but here with the auto-completion we can. So what's the name which let's take Lydia. Lydia is also here. So now we have people with first name Lydia, 516. We can check them out. That's where they are born. Okay. So, and this is something the Wikidata people are working on this. We are also working on this, that you can really you have a language model, you just give you a natural language description of the query, and then you get the query. That's it for my short presentation. Now Johannes and I are very happy to take your questions. Thank you.
Thank you so much, Hannah. There are many questions, so I will give them to you. So the first ones were from Peter. So QLever is much faster than BlazeGraph, is that correct? And when is it slower, if ever? What parts of the query service are missing in QLever, if any? Maybe you could talk to that a bit.
Yes, it's. I don't think it's slower for anything. I mean, it's just BlazeGraph is written in Java. QLever is written in C++. Yes. QLever is much newer.
I think we had in the last evaluation that we did, if you have very, very simple queries, which take like milliseconds on any engine, on those, there are other engines that are faster on sometimes. So if you just have a fixed starting point with a few triples and just do a very, very small single scan, this might be that since we are optimized, especially for medium to very hard queries, that sometimes very, very easy queries take like 60 milliseconds, where it can take 50 milliseconds on, for example, also on Virtuoso and maybe sometimes on BlazeGraph, but this is the only thing. As soon as there's something to do. Actually, BlazeGraph is also not a good competitor, because BlazeGraph also, among other engines which you can compare, is rather slow. So I think we're the fastest currently to what we know, but we know also of others that are faster than BlazeGraph typically, if that's.
So what was, thank you, Johannes. What was the second question, Lydia? The second part of the question?
What parts of the WDQS are missing from QLever, if any?
So that's a very good question. We are striving for full SPARQL 1.1 compliance. We are already there. But that's just a matter of months, I think. And what we did is we prioritized the things that people are actually using. I mean, there are things in the standard which are very esoteric. We didn't implement those yet for reason of times, but it works like this if somebody, but we are, yeah, our goal is clearly to fulfill the whole standard. And if somebody says this is missing, we really need it, then we usually do it. And the one bigger thing that's currently missing is, and we know it's very important for the Wikidata people, is update functionality. I mean, as I showed, you can, oh, yeah, by the way, I'm still sharing my screen, right?
Yes.
Yeah, so let's just check. That's how long did it take? 100. So this took 3 minutes to build this DVLP. That's 400 million triples. So you can load the Wikidata in 4 hours, but still many people don't care whether it's super up to date, 4 hours old, wouldn't matter at all to many people, but some people do care, which means you want to insert the real-time updates. And we already have a proof of concept for that. We haven't implemented it, but it's on our list in the next few months. So that's the one bigger thing that is still missing. Was there another part of the question, Lydia, that I'm missing?
I think you covered it all. Then the next question is, how frequently does QLever update when ingesting Wikidata?
Yeah,
and the same for OpenStreetMap.
We could update every 4 hours for Wikidata. The problem is right now the Wikidata dump is only renewed once per week because it's so big, and because I think probably you know more about this, David or Lydia. So we update whenever we get a new dump from Wikidata. And that's currently once per week because the dump is not updated more. But we could update much more frequently.
And for OpenStreetMap?
The same. We do it.
I mean, there's two parts to the OpenStreetMap. Yeah. Actually, that's also working. So actually, the OpenStreetMap is not in RDF format, but that's also a project that colleagues of ours mostly do, and which is converting the OpenStreetMap, protobuf, whatever format to Turtle. And those you can see at this page. You can download them there. Those are automatically updated weekly. I think our running QLever instance from this thing, I think we don't have an automatic update scale currently scheme there, but that's also could be done. But the raw data here, those Turtle dumps which we provide of OpenStreetMap as Turtle, those are automatically updated weekly for countries.
Yes. And I want to emphasize again that everybody is welcome to do it yourself because it's really quite easy. I mean, you can just download it, you do QLever index. If you have a machine yourself, you can do it yourself as often as you want. But we also update regularly.
Then a related question to the update. Is it possible for QLever to subscribe to the current Wikidata data stream, similar to WDQS, so that it doesn't have to wait for the weekly dump anymore?
Okay, I'm not sure. I think this relates to a question I myself have asked yesterday, is how do we get the updates? And I think we haven't fully understood the details, and maybe we should talk about this. How do we get the updates from? I think there is a way to get your updates currently, but it's not easy. We don't get them as triples, but we have to parse pages. So yeah, that's something we could work on if it's important for people, because in principle it would be easy to do. If we get the newest triples, then we just update as often as we can. So we would be happy to do that.
Yeah, and David and I can talk more about that with you. Cool. Then we have how many years did it take to develop QLever?
Yeah, we're working. I mean, we are in this kind of developing of search engines for 20 years already. So, but we started with normal text search engines. So this is kind of hard to answer because there are predecessor projects and predecessor projects. But I think this kind of work, maybe 5 years or a bit longer.
So I can say when I started working first on QLever was about 2018, and one of my first things was actually making it was there for a prototype of a SPARQL engine combined also with this full text feature. And the first thing that I did was basically making it scale so that you could load Wikidata in there. So that was, if you say that is since 2018, we are able to load Wikidata, and since then we are basically adding features for stuff, and since then also the these large knowledge graphs are our main focus of interest there.
Yeah, and yeah, thank you, Johannes. And let me maybe add to this. When we started, we actually thought the world doesn't need another SPARQL engine, so we were more interested in the special features like the auto-completion, which I've shown you, this thing where you can just so this, we thought, let's work on fancy stuff, like you get these suggestions here and that you can do text and geospatial. But then we found that there actually isn't a great SPARQL engine on the market. I mean, there are these SPARQL engines which work, but which are very slow. But if you want one that can do Wikidata or UniProt with 100 billion triples, there just isn't. So over the years, we shifted from just doing fancy stuff to also doing just the basic stuff, like doing a SPARQL engine, which just works on data set of any size. So this like wasn't our plan initially, but we just saw what people want, and that's what we're doing now.
Cool. Then we have some more minutes left. Are there plans to support SPARQL 1.1 update?
Yeah, that's, I think I answered that. Yeah, absolutely. So we have a prototype implementation which worked, and now we have to, we completely understand that people want it. And let me just say this one thing again. There's really, I would say, 80 to 90% of the people don't care whether the data is a day old or so. They just, I mean, not important for them, but 20% do care. And so we are, and also from other projects. I mean, people using it for many other data sets, and we also get this request frequently. And so, yeah, it's on our list. And realistically, I would say in the next half year, a matter of months.
Very cool to hear.
But it would definitely help if we had like a realistic way to get the Wikidata updates to like test the performance on a realistic update load, because I think we have I've heard this number that is about, what it is, 100 million edits.
1 million per
1
day,
million,
right?
1 million edits per day. Is that about realistic? So that should be Of course, we also want to do, if we don't want to do update, we want to do it for a little bit of scalability, but that's also, yeah, we'll work on it, but we also need the input to probably test.
Yeah, that would be great. If you would make your upstate stream a bit more accessible, that would be very useful. And we can, but I think we can do it, and it's on our short-term list now.
Excellent.
Yes.
Then we will see what we can do on our side.
Yes, thank you.
All right. Then, can a local QLever instance federate with QLever, with your instance, for example?
Sure. I mean, I could show it right now. It just probably takes a little too long. I mean, let's go back to, this is now the DBLP instance, which I just built. And now if I go here, let me just, is this, oh, this is still the Olympics one. That's strange. Oh no, I haven't updated the UI.
I think while you're doing this, I think typically every engine who has federated support can interact with any other engine as they only communicate via the SPARQL protocol. The only problem is, I think, the Wikidata Query Service instance, it has a whitelist for reasons of, okay, you want to do, for reasons that you say you disallow it, or you only say allow those features, but the implementation of it is not that.
So this is the instance we just built together in 3 minutes. So there's 3 minutes downloading the data. This is locally. That's why I've prepared this. About 400 million triples. It's the whole DBLP computer science bibliography. And here I'm just asking other people who've published in this venue, SICIR, SICM, ECIR, it's information retrieval conferences. Let's get their birth date. And that's the public endpoint, our public endpoint for Wikidata. And now I get DBLP people, and they are where they are born according to Wikidata. So yeah, that's, I think, the answer. It's nothing special here. Of course it works. You can just do it.
Cool. Then how much CPU time does a query in QLever consume, and how much does the same query need using Wikidata Query Service? Have you measured that?
Okay, this is something you can do yourself. It's a very good question and very. So let's take the Robert here. So of course we always display how much it takes, but we display much more information. So you can always look in query in detail, what did the engine do? So for example, here it looked at, I think these are all people with first name Robert now. There were 70,000 of them. And we attach the labels here. So there are 86 million labels. So you see exactly what the engine is doing at which point, getting this information and this, joining it together, then we get this information, then this. And it also has all the times here. So not only do you get the exact final query time, you also get how it's composed in the middle. I don't know about BlazeGraph. Yeah. I don't think you make that information available. Maybe BlazeGraph has it internally.
Yeah, and the point is, if you really want to know like CPU time, what time is it basically stalled on, how much energy does it cost, and what time is only spent like waiting for an input subsystem. We don't have most of those statistics, but I think generally, typically, currently, the most efficient thing to do if you're concerned about energy consumption is like the race to sleep, so that you have, if you're faster finished, also if you do it multi-threaded, it's always better if you're completely finished easier, because then you can have your resources available again. So that's.
And let me add again, everything I've showed you here was on a simple, it's a PC. It's not a high-end machine, nothing expensive. It's like €2,000 machine. That's very important for us. We don't want to write software where people need to buy special hardware. So I would say everybody with a normal machine can set up their own Wikidata instance, even on your laptop. It should work.
Maybe not the 10-year-old laptop. So that's for a laptop, it would have to be a nice one. So thank
you, Johannes.
That's
cool. Okay. Then next question we have here: does QLever support filter conditions in a SPARQL query?
Filter?
Mm-hmm.
I think we have seen, of course.
We have seen filter, but of course, in filter, basically that is where you basically can write the most queries that currently don't work, because in a filter you can basically write any expression that is allowed by the SPARQL standard, and we have worked on this a lot, but there are still some functions that are currently missing. For example, what we don't have currently is like the bound function, which is something that is very easy to implement. We haven't just done it yet, so that is why not every filter that is possible currently works. Actually, one of the chat members has sent me a query where something in the UI is broken, that if you use an unsupported filter function, then you get a only bad request. You don't get the nice message, which should be the filter is bound, is not implemented by QLever currently, and then you can properly raise an issue. And we also like where we focus our thing. If a lot of people say we want this, and we say okay, it's feasible to implement, and sometimes it gets prioritized, because as we said.
Thank you. And let me add to this. So here's an example for a simple filter query, mountains larger than 8,000 meters. So we get the 15 8,000ers. And I just saw in the chat briefly, filter not exists, is not yet implemented. That's correct. we could do it. It wasn't high on our list so far, but in 99% of the cases, this is equivalent to minus. And a minus is implemented, right? So minus, this is what we have. Let me just show it to you again here very quickly.
While you show that, maybe you can talk a bit about how people could help you prioritize. Like, should people open tickets somewhere, or how?
Oh yeah, that's absolutely how it works at the moment. So if somebody's missing something, they write an issue, and then we, yeah. I mean, that worked well so far. And if you're saying it's very important for me, very often we can say, look, you can just write it like that. SPARQL has a lot of redundancy. Excuse me. For example, filter not exists. In this case, you can just write minus, and then people are often already happy with that. And in case that's not the case, then yeah, we will try to work on it as quickly as possible. But it's getting, the delta is getting less and less what's actually missing for the standard. And it's really the esoteric things which are currently missing, like the things where.
All right, we have about 4 minutes left, so let's get through some last questions. Some time ago, we did the survey of different potential alternatives to BaseGraph. And there were some negative points. And how are you thinking about those now?
Okay, so since I'm not sure which negative, it would be good to know which ones. Of course, this survey is already 2 years old, I think now. Probably. And a lot has changed in the meantime. So I think there is no negative which will be a negative forever. So some negatives have already been addressed, like they are already implemented, and some others are on the short list. I don't think there's a single negative which is of the kind, sorry, we can't do this. It's all negative. The negatives which were there where it wasn't done yet, either it has already been done in the meantime. I think that's true for at least 50% of the points, and the others are on the short list. I think that's a correct statement.
Cool. And then we have, how can the QLever project benefit from the academic point of view in terms of funding, for example, if it's adapted by Wikidata?
So first, it would be, I'm not sure 100% I understand the question, but would be absolutely, I mean, we are 100% open source, and contributors very welcome. I'm not sure where it was written on my slide. So people are already contributing from other projects. So what we get a lot, people from other projects should have RDF data. They say, oh, I want to help with the project, and they are contributing code and everything. And people are very welcome to do that. But the question was the other way around, I think. How do we benefit?
Yes, yes. I think that's what this was about.
But what exactly was the question?
Like, would it be great for you if Wikidata were to adapt QLever? And in which phrase?
Okay, I'm not sure what the background of the. We are happy if this is used for other things. I mean, we are academics, and we are. I mean, we're making stuff. So, I mean, we are not in academics to make money. We're in academics to invent things which people use and which then make lives of other people easier. I mean, we have no, I don't know if that was the background of the question. We have zero commercial interest or anything whatsoever. So we are just happy if people are using it. I think that's maybe the best short answer to that. And it's already used in a lot of other projects. I mean, the protein people are using it, the chemistry people want to use it, the DBLP people are using it. I mean, it's just, yeah.
Great. Then one last thing. Andy asked, what's the possible roadmap for closer integration of this into Wikidata? What are the blockers? And I guess that's a shared question.
Yeah, what are the, I think probably update for you is so important that you want to wait before it's implemented. That's clear. And after that, I think it's, of course, your decision. I think you have to ask yeah, I think, yeah, I don't know if you have any reservations or.
Yeah, I think it would. So on our side, it is work, and before we start that work, we need to look into, okay, is this what we can commit to for the long term? What are the other alternatives now?
Yeah.
Because as you said, things have changed. But the fact that you're even here and presenting everything and have actually put so much time into developing it over the last 2 years, that's really, really, really great. Yeah. So
let me add. I don't think there are. If you want scale, I don't think there are so many alternatives really. So, but I totally understand the commitment. Yeah, and I would. Yeah. It's a commitment, of course, and we should talk about this. But one more thing I also wanted to add is we have been watching Wikidata. I mean, we love Wikidata. It's such a great data set. So I think we are already in many things close to what you guys are, because we have just been watching you for a long time already. So we kind of know how you do things, what you need, and so on. So I think there is a certain closeness already because of this, because it's not like we have been doing it and now suddenly, oh, there is Wikidata. As Johannes said earlier, one motivation was, oh, Wikidata doesn't work yet 5 years ago. Let's make it work. So we've been watching Wikidata closely, and this the consequence is a certain closeness in many things.
That's really amazing. Thank you so much. There is a lot of love for the project and you in the chat. There are some more questions which we unfortunately won't get to yet, but if people add them to the Etherpad, maybe you can answer them there.
Oh yeah, that would be happy to do.
Yes, and we also on GitHub, we don't have only, there's not only issues, which is like concrete, okay, this thing doesn't work or this thing is not supported, but I and all people I know really need it, but there's also the discussion tabs where you can put up more general discussions like, I want to further know how do you handle this, or what is your general plan, or I have this idea, would it be feasible? So we can also, this is where you can also reach us beyond this concrete event.
That sounds amazing. Thank you so much again for taking the time to do this introduction for everyone who hadn't heard of QLever before, and an update for those who had. Looking forward to see where this is going. Thank you so much.
Thank you very much, everybody. Thank you. And keep in touch.